Welcome everyone to our presentation on Project Prometheus. I'm Isaac, and these are...
I'm Brian.
Hi, I'm Roche.
I'm Denzel.
Okay, so our primary thesis question is, will agents trained by neural networks in potentially competitive environments emulate the behaviors of living creatures through the process of emergence?
So we have two sort of primary goals to our project. So the first one is to experiment machine learning agents put into an environment that aims to replicate and reinterpret early human sociology. And the second one is to explore what kinds of behavior unfold when neural networks engage in a community setting.
So our primary research areas are firstly the machine learning workflow, which is totally new to all of us. And then secondly, we're going to be trying to induce emergent behavior in these machine learning agents. And then we'll be exploring social interaction between AI. And then from there, we'll be exploring game theory as it relates to AI, especially in the context of social interaction. And then we'll also be exploring the dichotomy between competition and cooperation in potentially competitive environments.
Okay, so I'll be reading about the community impact and relevance. So our project, we want to create something that is a visual representation, like a visual project of the algorithms that govern our digital lives. So that's machine learning itself, right guys?
Yeah.
Yeah.
Sure.
Cool. So machine learning is something that exists all around us, and we're trying to make the aspects of it more visible and draw parallels between our society and machines as a society. We're moving towards the future where machines are more integrated in our lives and AI is integrated in our lives. And we kind of want to see if they fall into the same lifestyle pattern that we fall into, or if machines will have their own sort of society in the future. Like, will their lifestyle be more sustainable than ours? Will they live the same lifestyle as ours?
Okay. So in Ian Cheng's work, he really focuses on the character-driven narratives of machine learning and how they can be used in storytelling. So a lot of his algorithm is just focused on creating really interesting ways for the characters to interact with each other in the environment. And for us, we kind of want to take that a step further and apply those same themes in social settings and have groups of AIs kind of work together and try to achieve a specific goal while making their decisions very impactful on how they reach their goals. In the open and hide and seek game, the agents are fighting against each other directly to kind of gain the rewards. So one has to hide and the other one has to find the other agents. And they kind of have to come up with new solutions every time. That makes it relevant because that's exactly how we want to approach design in terms of our agents. We want them to take the basic principles, which is to get food. But in how they do that, we want it to be dynamic and different in almost every iteration. So that's why it makes it a very relevant work for us to study while we work.
This inspiration is particularly important in the context of our thesis because it specifically tasks multiple agents with learning simultaneously against other agents. So that's a unique property of this project.
Another really unique point about this piece of work is that that the agents in the video learned how to do all this emergently. So they weren't inherently taught how to do any of this, but over millions and millions of other iterations, they learned these emergent behaviors. And that's something that we're taking as a big inspiration for our project.
Haru's work is very special to us because of how she interprets the data. She takes a very, very abstract approach into community-based AI design, and we think that would be a very good resource for us in terms of how we decide to make the agents work together and how we depict it. The theoretical framework for this project centers around like, conflict-based interpretations of communication, and we just hope to show how the agents will interact with each other and what sort of behaviors come about that. Which leads to the next point, an abstract data graph that shows the trajectory of the symbiosis between biological and mechanical intelligence, which is basically how we incorporate AI into our lives. And if we have some sort of a grand or overall idea of what that looks like, it'll help us make better decisions in terms of implementing AI into our lives. Starting the conversation around it, getting people involved and getting them to understand what AI is rather than just have it be a back-end sort of tool to enable things we do. We want us to have an understanding of what AI's role is within society.
It seems like capitalist society is inherently doomed to fail. Socialism theory is where everybody works for each other. Will machine learning agents programmed in a capitalist society learn a better way of life than the one that we live now?
So at this current moment, we want to make a virtual environment that models real-time strategy games without the input of an external player. So in this case, the ML agents would be the players. So we're going to create an environment that allows for compromise between objectives and rewards. So the ML agents will have to decide for themselves and create the best strategy of how to win the game. So when designing the rules of the game, we've been following 3 fundamental human guidelines to sort of aid the development of networks and sort of allow them to develop parallels alongside human society. So the first one is every agent must eat, every agent must rest, and they also have a limited lifespan. To get more details about the simulation we're planning to build, so it's going to be a Unity environment, and there's going to be 4 different factions. So each faction will have their own set of worker agents, and so the goal of each faction would be to gather this common resource that's randomly placed on the map. And if they don't get enough by the end of the cycle of their day, then they could face penalties. And if they're number 1 by the end of the day, then they get rewards. So that's essentially the fundamental training loop that we're working with.
And we're going to achieve this by setting up some goals for us. Our work back plan includes 2 slots, the first being an ideation stage and the second being an implementation stage. So from September 21st to, I guess, October, we're going to be conceptualizing how the world's going to look, how we plan to use the ML agents algorithms, and also just start designing other stuff that we plan to use later in terms of like the audio, training the agents, experimenting with other ways of creating the agents or the goals we want to set, and just some basic setup for us to have an idea of what will work and what won't work. In the second week is where we're going to test all the stuff that we built in the first work back plan. So this one would be more focused on putting together some of the trained agents, refining a bit of our audio design and animations, and then just cleaning up things we don't need and adding things that we should have added in the first week.
We want to create a neural network that determines its own understanding of the space and how to communicate with others in the environment that it lives in. We want to create behaviors that help us interpret and reinterpret the way we understand conflict and resolution. And we want to understand the nuances and similarities between reinforcement learning in both biology and neural network training technology.
So some open questions that we have and that we'll probably continue to maintain until near the end of this project are, The question of will agents cooperate naturally over time? So we're really curious to see whether or not we will um, draw out some emergent behaviors of cooperation in the agents over the course of the thesis. And then, as an extension of that, how complex must reward systems be to produce lifelike behaviors in machine learning agents? So, in terms of scope in a reward system, we're curious to see how complex we have to get. And then finally, is multi-agent competition, as referenced in the OpenAI hide and seek project, where multiple agents compete as a means of training. Is that a more effective way to induce emergent behavior than traditional intrinsic motivation? So that's something that will remain to be seen.
So what we've done so far is all of us have begun using the ML Agents framework and sort of going through different tutorials, trying to really understand the library and get our hands dirty. Also, for the last couple of months, we've been theory crafting and sort of scoping in this project, looking at inspiration, seeing what we can and can't do, also seeing what else we can explore. So really, this presentation is a culmination of the last couple months of conversation we've been having amongst each other. We've been also doing some basic asset modeling, as well as, I guess, concept art. We went through the Spore character creator and sort of played around with it with the four of us on Discord, just seeing what kind of wacky characters we can make and potentially what could be in our simulation. So yeah, that's Project Prometheus. I hope you guys are excited as much as we are to make it, and hopefully we get some really good results. Thank you.